flood produced radioactive elements, then many mysteries of Earth's radioactivity are explained. Radiometric dates are meaningless. For evolutionary theory, the alleged mountain of data in support of great uniformitarian epochs of time really adds up to nothing more than a very precise set of ratios, not dates. But how does hydroplate theory tie Earth's radioactivity to a recent global flood? The key to seeing how Earth's radioactivity is concentrated in Earth's continental crust is to recognize that the main rock found is granite. Unlike basalt that covers the ocean floors, granite contains a great deal of the mineral quartz, about 27% quartz. Quartz crystals are arranged in such a way that they will produce an electrical potential, or a voltage, if they are stretched or compressed. Such materials are said to be piezoelectric, piezo meaning pressure. Ever wonder how your gas grill can light the propane by simply pushing a button that has no battery? The snap you hear at the end of the button stroke is a spring slamming into a quartz crystal, causing it to compress and give off a spark, igniting the gas. Here is a similar device that allows us to see what is happening without tearing apart your grill. A child could push or pull on the lever and produce enough pressure in the small quartz pellet to produce a 4,000-volt spark. Imagine the voltage produced on a continental scale instead of this display. Some may ask what evidence there is that granite could produce electrical charges. Here are some quotes taken from eyewitnesses around the world. Of course, today, many witnesses have uploaded YouTube videos of these strange lights during large earthquakes. Many scientists have begun to link the root cause of these accounts as being due to the piezoelectric materials in granite being stressed during an earthquake. Hydroplate theory shows that during the flood, the granite continents were exposed to more extreme cyclic pressures on a much larger scale. Hydroplate theory poses that during the beginning stages of the flood, as supercritical water rocketed out from under the fractured plates, water flowing under the plates, in combination with seismic waves sent throughout the plates, due to the buckling failure of the plates' supporting pillars, induced flutter in the granite plates. So what is flutter? Whenever a fluid flows over a flexible surface, a vibration or flutter can be induced. This is easily seen in a flag flapping in the wind. Flutter is a phenomenon that must be considered in designing aircraft structures like wings to prevent their fatigue. So what evidence is there that Earth's massive granite continents once fluttered? Lineaments are very long parallel fractures that have been observed on the surface of Earth's continents. Some unique properties of lineaments are that the material on either side has not been displaced and does not change in elevation. We can postulate several failure mechanisms for these features of lineaments. However, only one is consistent with observation. Looking at compression, we see that compressive failure or crushing or impacts would not produce long, thin cracks, but many randomly directed fractures and displacements. The continent could have sheared, but shearing would produce displacements. Horizontal tension may be an option, but horizontal tension would pull a slab of rock apart at one single point of failure and not produce multiple parallel fractures. Finally, consider tension in bending. This mode will produce multiple parallel fractures in a material. Rather than displacing, they will simply close back together once the bending load is removed. Of these failure modes, lineaments seem most likely to be tension cracks formed due to bending at some point in history. Here's how lineaments formed due to flutter. The wave that flutter produces causes a structure to bend back and forth as it flexes. This flexing produced the long, undisplaced parallel fractures we see today on the surface as lineaments. Think of a simple two-dimensional beam as loaded, shown here. Notice the parallel red lines at the ends of the beam. The loads will cause the beam to deflect into an arc. The convex side is in tension as the material stretches past the red lines. The neutral axis of the beam in the middle is neither in tension or compression. The concave side is in compression, as the material is squeezed between the red lines. While granite has excellent compression strength, its tensile strength is very weak. This property of granite, combined with the bending from flutter during the flood, produced the lineaments we see today. During the flood, continental hydroplates began to flutter as an ocean of water flowed under and burst out of the crack. Piezoelectric quartz fills these granite plates, which were exposed to cyclic tension and compression that produced huge voltages throughout the granite. Just as the dielectric strength of air breaks down in an electrical storm, granite's dielectric strength was exceeded, resulting in powerful electrical surges, or plasma, arcing within the fluttering plates. Each time the supporting pillars were lifted and then slammed down into the mantle floor, tremendous compressive pressures crushed the pillars. Like the Proton 21 lab experiments, self-focused Z-pinches occurred at microscopic points within the pillars. The high temperatures, on the order of 630 million degrees Fahrenheit, at each point was enough to melt a millimeter or two of surrounding rock, creating small chondral spheres. Some of these fragments were launched into space and fall back to Earth today as meteorites. A bit later, we'll discuss how these tremendous velocities were achieved. The arcing lightning, or plasma, strips nearby elements of their orbiting electrons. In this case, the elements involved in the Z-pinch were those that comprised of granite rather than air. The elements that make up granite were vaporized into a plasma state, stripped of their electrons, setting up the conditions for the Z-pinches to occur. Next, we'll see a second mechanism that could have aided in heavy nucleus building. Lightning in the deep granite led to further nuclear fusion via shock collapse events. As rock became plasma along the thin pathways of the electrical discharge, the shock wave generated by the electrical heating suddenly expanded the plasma and the surrounding rock walls. With air, the shock wave causes thunder. However, the deep granite was not able to expand like air. Instead, the surrounding rock walls were momentarily expanded by the shock wave, but then rebounded like a giant compressed spring from all directions. The rock collapsed back into the plasma with enough shock energy to drive or fuse the nuclei together at various places along the plasma paths. This happened frequently deep in the crust where the rock was already highly compressed. As can be seen, light nuclei that make up granite, like silicon, oxygen, magnesium, iron, aluminum, fluorine, calcium, potassium, and sodium, were Z-pinched into super heavy, highly unstable elements, which then fissioned rapidly and randomly produced many new elements and their isotopes, some of which were heavy and radioactive, like uranium, thorium, polonium, radon, etc. In addition to producing all kinds of new, heavy, unstable elements, another series of chain reactions would have occurred at the nuclear level within the granite plates. These reactions transferred much of the generated heat into the subterranean water. In addition, they also caused accelerated radioactive decay of newly created heavy elements. This massive electrical plasma storm surged within the granite and produced a sea of flowing, accelerating electrons, which passed close by surrounding granite nuclei and any newly formed elements. This decelerated or accelerated the high-speed electrons, producing secondary Bremsstrahlung radiation. Bremsstrahlung is a German term for radiation produced by either decelerating or accelerating an electron. The result was the release of a photon. These high-energy photon showers were accelerated and decelerated by the surrounding nuclei, which in turn produced a sea of free neutrons. Many of the nuclei affected by these electron, photon, and neutron showers were the newly formed fission fragments of unstable radioactive heavy elements. In this unique and turbulent environment, these nuclei experienced accelerated radioactive decay rates that were orders of magnitude faster than the decay rates measured today. Missing the evidence of this catastrophic event gives many the false impression that eons of time have passed because of the ratios they measure. However, we can see that this new theory of events shows that these ratios have nothing to do with age. In the lower levels of the plates, where for centuries prior to the flood, supercritical water had eaten innumerable porous channels up into the granite, the surging sea of free neutrons released in the granite were thermalized, that is, slowed down by the subterranean supercritical water. As a result, nuclear energy was transferred from the granite into the subterranean waters that were escaping to the surface and beyond. Some have scoffed at Walt's theory of nucleosynthesis occurring in granite, citing that the heat buildup from fission of these super heavy elements would have vaporized the entire crust. From this, they conclude the theory is invalid. However, they have overlooked or ignored important details of the process. So let's discuss this alleged problem of too much heat. Remember this binding energy chart we had looked at. For elements lighter than 60, fusion results in higher binding energy, which does emit heat. However, fusion of nuclei heavier than 60 causes a drop in binding energy, which means the event absorbs heat from its surroundings. This is why the Proton 21 lab reports that the process produces a cold packing of materials, and that the overall process, in spite of many secondary fission events, remains nearly adiabatic, meaning little heat is transferred to the surroundings. So while we'd expect the crust to see some heating, it certainly would not have completely vaporized or melted, as some mistakenly conclude. So how was excess heat removed from the crust? Anyone who deals with heat transfer knows the purpose of these strange-looking fin features seen on engines. Friction and burning fuel creates heat that can destroy an engine. By increasing the external surface area of the engine block, more heat can be transferred to the cooler air outside, preventing the destruction of the engine. Instead of fins, when extremely efficient heat transfer is required, designers will use specialty products like porous aluminum foam to rapidly transfer heat. If supercritical water had not dissolved thin channels into the lower depths of the granite, the small surface area of the crust would have resulted in rapid heat buildup within the crust. However, the porous channels function much like the fins on an engine and greatly increased the effective surface area within the lower crust. Therefore, large amounts of heat generated by the nuclear level reactions within the crust was transferred quickly into the supercritical water below. We'll now examine the effects this heat transfer had on the supercritical water and soon see the results. Let's look at the molecular level to see what happened to the supercritical water that filled the porous granite. As discussed, some fast neutrons released by bremsstrahlung radiation thermalized the porous channels full of supercritical water, thus transferring energy and producing much deuterium and oxygen-18 in the supercritical water. Energy transfer in the supercritical water causes simultaneous evaporation of the fluid's liquid droplets into vapor. Evaporated gases expand the fluid, which pretty much had nowhere to go but down, so this greatly pressurized the escaping subterranean waters below the crust all along the flow. The supercritical water, as well as any dissolved minerals and fragments of crust pillars, were accelerated by this continuing pressure. This material was then launched and continued to accelerate high above the atmosphere. Some of it achieved high enough velocity to escape Earth's gravitational sphere of influence. The constant tumbling in the turbulent flow and sudden ejection into near absolute zero temperatures of space kept newly formed chondrules in the pillar fragments spherical, and the rapid freezing trapped many volatiles inside. Today, some of these strange rocks fall back to Earth as meteorites.